Okay, here's a video solved by taking square roots. These are the steps. You isolate the x squared in a quadratic equation. That means you get it all by itself. And then everything else is on the other side of the equal sign. And then you undo the x squared by taking the square root. When you take the square root, you add plus or minus. This is plus or minus. And that gives you the two solutions to quadratics. All quadratics have two solutions. And then the next step, I think you should split out those solutions into two values of x, or of the variable you're solving for. And then check your answers. Okay, if you remember, if we have x squared and we take the square root, if you remember, when you take the square root, it's like writing it x to the 1/2. That's how you write it as a rational. And so, if you take the square root of x squared, you do it to the 1/2 power. When you multiply 2 times 1/2, you get 1. So you get x to the 1. So this is why, when you have an x squared, a square root basically undoes it or solves it for x equals 1. Same reasoning like behind this. If you were multiplying 2 times x equals 10, to undo multiply, you divide. Or if you're, because they're called inverse operations, multiply and divide. If you're going to add x plus 2 to equals 10, you subtract 2, you get 8. So these are additive inverses. They add to 0. So that's sort of the why of why this works. Here's an example. 3x squared plus 7 equals 55. So to get x squared by itself, you subtract 7. So then you get 48. You get 3x squared equals 48. To get x squared by itself, you divide by 3. It's the next algebra step. And then you have x squared equals 16. And to solve that, you take the square root of x squared of both sides. When you take the square root, that's where you get plus or minus 16. I think maybe it's kind of thinking backwards that, if you had this right here, 4 squared would be 16, and also negative 4 squared would be 16. So these are the two answers. And then to check them, you plug them back in to the original problem for x. Here's another problem. Parentheses x minus 3 squared minus 81 equals 0. So I add 81. So then the squared is by itself. Then you take the square root to get rid of the squared. You have this, x minus 3 equals plus or minus 9. Next, to finish, you add 3 to both sides. So you get this as your answer, plus or minus 9 plus 3. So this is where step 4 comes in. That's kind of ugly, plus or minus 9 plus 3. But what it means is 9 plus 3 is 12, and negative 9 plus 3 is negative 6. So these are the two final answers, 12 and negative 6. Next problem starts out like this. 5x squared equals 60. So first thing to do is divide by 5 to get the x squared by itself. So then you get x squared equals 12. To solve this part, you take the square root right here. Square root of x squared. And square root of 12. So the square root and the x squared cancel. You get plus or minus root 12. You break that root 12 down into its prime numbers, and you simplify. So you get 2 root 3 and negative 2 root 3. Okay, I think this is the last one. The problem starts out as x squared minus 5 equals 0. So to get x squared by itself, you add 5. Then you take the square root of both sides. You get plus or minus square root 5. This is how you write out two answers. Let's pretend I was going to do this one more. X squared plus 5 equals 0. Okay, so my first step would be subtract 5. Next step, take the square root of both sides. So you get x squared equals, well now that's weird, but remember we just call it I, plus or minus I root 5. Imaginary numbers can also be solutions. There can be two imaginary numbers, plus I root 5 and minus I root 5. All right. Thanks for watching.